Dear students, very good morning. Today we are going to discuss about Taylor series. Taylor series expansion is used to combine the partial order derivatives by means of expression given by f of x comma y, given by f of x comma y equal to f of a comma b plus 1 by 1 factorial h fx of a comma b k fy of a comma b plus 1 by 2 factorial h square fxx a comma b plus 2hk fxy a comma b, then k square fy a comma b plus 1 by 3 factorial h cube fxx x a comma b 3h square k f double xy a comma b plus 3hk square fx double y a comma b plus k cube f yy a comma b plus etc. So where h equal to a comma b and y equal to k equal to y minus b, and also we know that what is fx, what is fxx, and so on. So fx is nothing but the partial derivative of the given function f of x comma y with respect to x. Fy means the partial derivative of f of x comma y with respect to y. So if I want to find fxy means it is the partial derivative of the previous term fy with respect to fy with respect to x. So that is dou by dou x of fy. So we are having this expansion. So this expansion is nothing but I am defining. So f of x comma y be a function of two variables. So what are those two variables? X and y be those two variables. So we can expand it by means of Taylor series. So Taylor is a mathematician who first expanded a series depending on the partial derivatives. About the point a comma b, okay, and such expansion is given by the terms inside a box, okay, the equation inside a box. So what is f of x comma y? F of x comma y is f of a comma b. First term, it is very easy. The second term is nothing but 1 by 1 factorial of h fx of a comma b plus k fy of a comma b. So you just keep in mind capital A plus B, 1 by 1 factorial of a comma b. You just keep it in mind, okay. What is our a? Our a is h fx a comma b plus k fy a comma b, and after that we have to use 1 by 2 factorial of, so after 1 by 1 factorial we have to use 1 by 2 factorial of a plus b whole square. So what is our a? h fx a comma b. So a plus b whole square means we get first term as a square, that is h square f xx a comma b. So what is b square? Since b is k fy a comma b, our b square is k square f yy a comma b, that is this term. So what is 2 into a into b? Because expansion of a plus b whole square is a square, okay, a square plus a square plus 2ab plus b square. So 1 by 2 factorial of this, okay, 1 by 2 factorial of this. So we have the expansion of a plus b whole square here, okay. So 2 into a into b means 2 into h into k f xy a comma b. So what will be the next term? The next term is given by 1 divided by 3 factorial, 1 divided by 3 factorial, okay, 1 divided by 3 factorial, and then we are having a plus b whole cube. So what is the expansion for a plus b whole cube? A cube, okay, plus 3a square b plus 3a b square plus b cube plus b cube. So just expand this 1 by 3 factorial. So a cube means what is a? H of x, a comma b. So a cube means h x cube. A cube means f x x of a comma b. And 3a square b, that means a is 2 times and b is 1 time. So 3 h square, since a is 2 times, what is our a? X, fx. So f x x, what is b? Fy. So f x x y. So 3h square k fx x y a comma b plus 3a b square, which means a comes 1 time and b comes 2 time. So 3h k square, because a comes 1 time, b comes 2 times. 3h k square f, since a comes 1 time, fx, b comes 2 times, yy. So 3h k square f x y y a comma b plus b cube. So b cube means k cube f y y y a comma b plus etc. So this is the formula. So we are having h equal to x minus a and k equal to y minus b. So now definitely you will not have any idea about what is h and what is k. They are very simple. A and b are the points. We want to find the Taylor series expansion about those points. So h is equal to x minus the first point of the pair. Okay, so that is a, and b is the second point of the pair. So they will give find Taylor series expansion about the point a comma b. So from those terms we can find a comma b. Okay, from those points we can find a comma b. Now I hope you have understood this formula. So this formula is very important, very important. Okay, now we shall move on to our first problem. So our first problem is expand e power x cos y about the point 0, pi by 2 up to third term using Taylor series. First question, and this question can also be asked as expand e power x cos y in powers of x and y as far as the terms of the third degree. One is it can be asked as up to third term, or it can be asked to expand the terms of third degree. So up to third term or third degree, both are same. So expand using Taylor series or expand in powers of x and y are same. So question can be asked in both the ways. Okay, so now the given function is a function of f of x comma y. Given function is a function of x comma y. So f of x comma y equal to e power x cos y. So these 2 points are a comma b. So now we know the formula and we want to find the terms involving in those formula. First we shall write the formula. So by Taylor's theorem, what is the formula? So by Taylor's theorem, so by Taylor's theorem we know that f of x comma y equal first term f of a comma b, second term is 1 by 1 factorial of a plus b, 1 by 1 factorial of a, okay, a plus b, okay, plus 1 by 2 factorial of a plus b the whole square plus 1 by 3 factorial of a plus b the whole cube, a plus b the whole cube. Okay, so you have to keep in mind f of a comma b plus. So what is our capital A? What is our capital A? Our capital A is H. Okay, capital A is H into fx a comma b, or capital B is K into fy of a comma b. Okay, so if you just remember this formula, you can easily remember the Taylor series expansion. Okay, here what is A? Here in this problem? A is 0, B is pi by 2. So we want to find, see the formula, we want to find fx. See, since it is PDF, it will not support very kindly. So we want to find fx. We want to find fy initially. After that, fxx, then fxy, then fyy. After that, fxxx, fxxy, fxyy, then fyyy. Okay. So we want to find all these terms. So here we are going to find those terms. So what is f of x comma y? F of x comma y is e power x cos phi. So when I differentiate it with respect to x, I will get fx. So the differentiation of e power x is e power x, and in this, since we are differentiating partially with respect to x, cos y x as constant, so we get e power x, which is derivative of e power x, and cos y is constant, so we get e power x cos y. Suppose if I differentiate it with respect to y, here e power x is constant and differentiation of cos y is minus sin y. Okay, and now we want to find f double x, which means I want to differentiate this fx again with respect to x. So I get the same term e power x cos y. If I differentiate it again with respect to x, once again I will get the same term, because all the times cos y is constant and all the time the derivative of e power x is e power x. So the terms will not be changed on differentiating it up to 10 degree or differentiating it up to n degree. Okay, so fx, fxx and f are same. Now what is fy? E power x sin y. Now I want to find fxy, which means I want to differentiate fy with respect to x. So here already there is a minus, so that minus will be outside. So the differentiation of e power x is e power x. Okay, e power x, and since sin y is constant, it will come as it is. So we will have minus e power x sin y as it is. So fxy is same as minus e power x sin y. And once again, if I want to differentiate it again with respect to x, that is fxxy, means once again there will be minus. The differentiation of e power x is e power x. So and since sin y is constant, when we are differentiating with respect to x, we get the same term. So minus e power x sin y, Now we want to find fx with respect to y, that is fyx. When I differentiate with respect to y, we get fyx. So when I differentiate with respect to y, e power x is constant. The differentiation of cos y is minus sin y. So we get fyx. Where is fyx? Since we are right, we don't want fyx. Instead of that we want Just a minute. Instead of that, we have to check with the formula. We want fx, fy. Okay, we have found that fxx, fxy. We have found that fy. We have found it. Now we want to find f triple x. We have already found f triple x, and we already know we want to find f x xy and f x double y and f triple y. We want to find these three terms, so we shall find these three terms. Okay, so f triple x is same as f double x, and if I differentiate f double y, with respect to x, I get again the same term, because cos y is constant, e power x is e power x itself, since the derivative of e power x is e power x with respect to x. So I get the minus, so I am having f x double y equal to minus e power x cos y. So f triple y is differentiating it, only this term is the changing term. Okay, only this term is a changing term. So when I am differentiating f double y with respect to y, we get e power x as constant, and the differentiation of cos y is minus sin y. So already there is a minus here, so minus of minus will become plus. So we are having plus e power x sin y, plus e power x sin y. Okay, so we are having plus e power x sin y. Now we want to substitute the points 0, pi by 2, 0, pi by 2. So we know that you can use calculator also. So if you want to use 0 and pi by 2, you can simply use the mode, the radian mode. If you want to use angle, means you have to change it to degree mode. Okay, so degree is 0 degree, and pi by 2 is 90 degree. Pi by 2 is 90 degree. Okay, because the value of pi equal to 180 degree. Value of pi is 180 degree. Here pi by 2 is doesn't mean 3.14 by 2, or pi by 2 doesn't mean 22 by 14, because sometimes you may think pi equal to 3.14, pi equal to 22 by 7. So automatically your mind will think pi by 2 means 3.14 by 2 or 22 by 4. It is not like that. In trigonometry you will have angles. So pi equal to 180 degree, pi by 2 means 90 degree. Okay, so we have to substitute. So here when I substitute x equal to 0, since x deals with the normal point, it is not angle, so it is e power 0. E power 0 is 1, and cos pi by 2, that is cos 90. Cos 90 is 0. So 1 e power 0, that is 1 into 0 is 0. Okay, and e power x cos y is again 0, and minus e power x sin y. So sin 90 is 1, minus e power 0 is 1. Anything power 0 is 1. So minus 1 into plus 1, you get minus 1. Here e power 0 is 1, cos 90 is 0, so 0. Here e power 0 is 1, sin 90 is 1, so minus 1 into 1 is 1. Here e power 0 is 1, 1 into cos 90 is 0, so minus 1 into 0 is 0. Here e power 0 is 1, cos 90 is 0, so 1 into 0 is 0. Here minus e power x, that is minus e power 0 is minus 1 into sin 90, that is 1. So minus 1 into plus 1, minus 1. And here we are having minus e power x cos y. So once again you get 0. E power x and y, you will get plus 1. You get plus 1. Then you get plus 1. Finally you are having all the values for these terms. So that is why you are going to substitute here. You are going to substitute at 0, 0. Why we want to substitute it 0, 0? Why we want to substitute it at 0, 0? Actually we are having the formula a equal to 0 and b equal to pi by 2. A equal to 0 and b equal to pi by 2. So initially we are having f of a comma b. Okay, f of a comma b, This is our second question. Okay, this is our second question. Second question we are having, just a minute, since it is PDF, it is not supporting me very fluently. Degree. Okay. So in our first question we want to find the Taylor series expansion about a point 0, pi by 2. But in the second question we want to find the Taylor series expansion, but they have not mentioned about what point we want to find. So here so for second formula we are substituting a equal to 0 and b equal to 0. Okay, for the first problem we are substituting a equal to 0 and b equal to pi by 2. Okay, for second question, since they have not given the points about what we want to find expansion, so we have just taken a equal to 0 and b equal to pi by 2. So what is h? Always you have to keep in mind h equal to x minus a, and k equal to y minus b, so x minus a means it is x, and y minus b means it is y minus pi by 2, so here in the formula f of a comma b means you have to substitute, instead of f of x comma y you are having f of a comma b. So what is our f of x comma y? Our f of x comma y is e power x cos y. Number 8, e power x cos y, so that is e power, what is x? Okay, what is x? E power x cos okay, see e power of just a minute, I am substituting the value where we have used that value in h and h square. So in h and h square only we have used that value, so we are substituting h equal to x minus a, that is in the place of h we want to substitute x, in the place of k you want to substitute y minus b. So we are having e power x cos y as a f of x comma y, so in the place of e power x cos y we want to substitute a comma b, a equal to 0, that is e power 0, cos y means cos pi by 2, cos that is 90, cos 90, that is 0, e power 0 into 0 is 0, so our first term will become 0. Okay, that is what we have found in the table, f of a comma b equal to, see, f of a comma b, f of x comma y at the point is f of a comma b, this is f of a comma b, this is f of a comma b. Okay, now you want to substitute all the values in the formula. Okay, and after substituting the values in the formula you get, after substituting all the values in the formula you get f of x comma y equal to 0 plus x into 0 y. This is what is this? This is x minus a into fx h, that is h fx of a comma b plus, number 8, f of, see the formula, f of a comma b plus h fx of a comma b plus k fy of a comma b, that is our formula. See the formula, f of a comma b, h fx of a comma b plus k fy of a comma b whole divided by 1 factorial. Here it is 0, h is x minus a, k is y minus b, so h is equal to x minus 0, k equal to y minus pi by 2, and we are having fx and fy. fx and fy values are 0 and minus 1, so we are substituting these values here. So first term f of a comma b is 0, h is x, then the first term 1 by 1 factorial is 1 by 1 factorial whole, that is here you will have 1 by 1 factorial, 1 by 1 factorial is again 1 plus y minus b into k, okay, that is sorry k into fy, okay, that is 1 by 1 factorial h fx of x comma y plus k fy of x comma y, okay, that is our formula. So we are substituting all the values in the formula here. Now we want to expand it. So what is our expansion? We are getting x into 0 is 0, y into minus 1 is minus y, minus pi by 2 into minus 1 is plus pi by 2, 1 by 2 factorial into this term x square into 0 is 0, 2xy minus 2x pi by 2 into minus 1, so minus 2xy by 2 factor is taken outside, then minus into minus is plus, we are having 2 factorial is taken outside, so we are having 2 and 2 will get cancelled, x into pi by 2, but they have not cancelled. Actually these two terms will get cancelled, these two and these two will get cancelled. You may think like that, but actually it is not like that. You should not cancel, okay, you should not cancel. Why we should not cancel it? Because the pi by 2 here comes for cos term, which will be taken as angle, okay, so we are not supposed to cancel that. You just keep, okay, see, it is not necessary to simplify all the steps in odd occasions. Sometimes simplifications may lead to a wrong answer. Just keep the steps as it is, okay, that will be your final answer, and finally you will have 1 by 3 factorial of these terms, okay. So the sum is over, and for the second problem they have not given about what points we want to find, okay. So our second question is find the same expansion powers of x and y as far as the terms of the third degree, but they have not mentioned about what points we want to find. So since they have not mentioned about what points, the points are empty here, the points are not mentioned, so we are taking a comma b as 0 comma 0, and I am finding all the partial derivatives as we have done in the first subdivision, and I am also finding all the values as we have done in the previous subdivision, and now we are substituting the values in the Taylor series expansion, and now we are getting this. So a equal to 0, b equal to 0, so h equal to x minus a is x itself, k equal to y minus b is y minus 0, that is y itself. So f of a comma b is 0, 1 by 1 factorial of x, that is h into fx of x comma y at a comma b, y into fy of x comma y at a comma b, that is a comma b, okay, so after substitution of values we get the following expansion: 1 plus x by 1 factorial plus x square minus y square by 2 factorial plus x cube minus 3xy square by 3 factorial plus etc. So maximum they will ask for degree. So the second problem is similar to that of previous problem, but instead of x equal to 0 we are having 1, and the angle, the point y is same, that is pi by 2, so we are having e power x sin y. So here we can find fxy about a point a comma b, that is this is f of a comma b, equal to f of a comma b equal to e power 1 sin pi by 2. Sin pi by 2 is sin 90, that is 1. E power 1 is e. So e into sin pi by 2. E power 1 into e power 1 into sin pi by 2. Okay, e power 1 into sin pi by 2, that is e into e power 1 into sin pi by 2. Sin pi by 2 is 1, so we are having e into 1, that is e. Okay, so in the same way we want to proceed, and finally we are having a formula. In that formula we want to substitute. You know how to easily memorize the formula. Actually it is not memorizing, you have to understand what kind of expansion is this. This is nothing but f of a comma b. I am repeating the formula for the third time, I think, for you to understand. So f of a comma b plus 1 by 1 factorial of a plus b plus, okay, a plus b, okay, and then 1 by 1 factorial of a plus b plus 1 by 2 factorial of a plus b whole square. A plus b the whole square. Okay, a plus b the whole square plus 1 by 3 factorial of plus 1 by 3 factorial. Okay, 1 by 3 factorial of a plus b whole cube. A plus b whole cube. A plus b whole cube. Okay, plus etc. So the only thing you want to keep in mind is what is a and what is b. What is a and what is b. A equal to, say, plus etc. Plus etc. So what is a? The few things. A equal to h. Okay, h. A equal to h fx of a comma b. Okay, plus what is, sorry, it is not plus, b equal to k f y of a comma b. K f y of a comma b. Okay, you have to keep these things in mind. And another thing is x minus a equal to h. That is h equal to x minus a. K equal to y minus b. K equal to y minus b. You have to keep only these things while solving a problem under Taylor series expansion. So for this problem we are having f of x comma y equal to e plus x minus 1 into e plus 1 by 2 factorial of x minus 1 the whole square into e minus y minus pi by 2 whole square into e plus 1 by 3 factorial of x minus 1 whole cube into e minus 3e of x minus 1 y minus pi by 2 whole square. The sum is very simple. Okay, the steps are very simple. The formula is also very simple. Only thing is you must have enough practice to solve the sum efficiently. Okay, now you are having another function. For this problem you are having another function sin xy. So inside the angle there is a product. So sin xy is also a function of x comma y. So for this function we want to find the Taylor series expansion about the points about the powers of x minus 1 and y minus pi by 2, that is x minus a, about the points x minus a. So the question will be sometimes like this also, about the points x minus a and about the points y minus b. Okay, the only thing is that you have to consider points which is not having x and y. So and it should be like h and k. It should be like h and k. The points h and k resembles x minus a and y minus b, no. So the point should be like that if it is mentioned like x minus something and y minus something. So here x minus a means x minus 1. So here a equal to 1. So here a equal to 1. You should not take a equal to x minus 1. Here a equal to 1 and b equal to pi by 2. B equal to pi divided by 2. B equal to pi divided by 2. Okay. So with these points we can easily expand sin xy. So differentiation of sin xy means first differentiation of sin will gives cos. Okay, then the differentiation of xy with respect to x gives 1 into y. So we are having yxy. And if suppose I am differentiating sin xy with respect to y, means once again the differentiation of sin is cos. Since this xy can be differentiated with respect to y, on that occasion y is treated as variable and x will be treated as constant. So I will get a constant as it is, so it can be x cos y, x cos xy. So in the same way we can also find fxx. So here we are having already one y. So differentiation of cos xy is minus sin xy. So this sin xy, this xy can once again be differentiated with respect to y. So with respect to x, which gives y again. So we are having minus y square sin xy. Okay, and now I am supposed to differentiate y with respect to x. Y with respect to x. So here x is an algebraic function and cos xy is a trigonometric function. According to ILATE, that is according to the hierarchy of giving preference of choosing u, we have to choose u as a trigonometric function. I am choosing u as trigonometric function, that is u as algebraic function. So x is here u. Okay, so u v dash plus vu dash when I am differentiating fy with respect to x. So x into differentiation of cos xy. So we are having x into minus sin of xy into y, that is minus xy of sin xy plus u v dash, that is cos xy into 1. So it is plus cos xy. So this is the value of fxy. They have only asked up to second degree terms. So we want to find fyy. Fyy is, I am differentiating y again with respect to y. So here x is constant, minus cos will be differentiated to give minus sin xy into x. So minus x square sin xy. Now we have to substitute 1 for x and pi by 2 for y. So we get 1 into pi by 2 is pi by 2. So sin pi by 2 is 1, that is sin 90 is 1. So cos 90 is 0. Cos 90 is 0. Again here also cos 90 is 0. Here sin 90 is 1. Y is pi by 2. So minus pi by 4 into pi by 2 whole square. So minus pi square by 4 into 1. Here we are having the cos xy will become 0 on pi by 2. And here we will have pi by 2 is 1. So minus 1 into pi by 2 is minus pi by 2. And here sin pi by 2 is 1. So minus 1 square is minus 1, so we are having minus 1. Now we are having values for the partial derivatives involved in the formula up to second degree. So up to second degree means we have to stop it up to a plus b whole square by 2 factorial. A plus b whole square by 2 factorial. We have to stop it here itself. Okay. So what is a? F(x) of hfx of a comma b plus kfy of kfy of a comma b the whole square, that is h square fxx a comma b plus 2hk fxy a comma b plus k square fyy a comma b. That is what I have mentioned previously. What is a, what is b? Okay, what is a and what is b? Okay, here I have mentioned now, so that you should keep in mind always. Okay, now we are having this expansion. Okay, now we are having this expansion. In the same way we can also find, okay, so h is x minus a, k is y minus b. Okay, so we are substituting the value of h and k also in the above expansion. So we are having the expansion 1 plus 1 by 2 minus y pi square by 4 of x minus 1 whole square. So this is nothing but 1 plus h fx a comma b plus k fy a comma b. This is h square fxx a comma b plus 2h fx a comma b into fy a comma b plus this term. What is this term? K fx. This is 2hk fxy a comma b plus this is k square fyy a comma b. Okay, substituting the values you get this. You have to keep the formula very clearly in mind. So here they have given 1 and 1. Sometimes it may be asked like x minus 1 and y minus 1. Sometimes it may be asked like x about the points x minus 1 and y minus 1. So you should not think a is x minus 1 and b is y minus 1. You have to take only a equal to 1 and b equal to 1. A equal to 1 and b equal to 1. Okay, so we shall discuss the remaining problems tomorrow. So here there is one important problem up to 3 degree. Here it is e power x log of 1 plus y. So it is also function of x comma y. The first term is function of x and second term is a function of y. So when I am differentiating with respect to x, only e power x will be variable, log of 1 plus y is constant. When I am differentiating log of 1 plus y, it is, when I am differentiating with respect to y, log of 1 plus y will be variable, e power x will be constant. So this one sum we shall discuss now, and we will have, if I differentiating with respect to x, we are having the same term e power x log of 1 plus y. If I differentiate fxx, f triple x, I will get the same term again and again, since log of 1 plus y is constant for all the time, and e power x, the derivative of e power x is same when in differentiating even it for n number of times. So we are having the value e power x log of 1 plus y is common for fx, fxx, f triple x. Okay, then we are having fy. Now we want to find fy. So here e power x is constant. When I am differentiating a logarithmic function, I will get 1 divided by 1 plus y, that is 1 plus y whole inverse 1 plus y whole inverse into, when I am differentiating this 1 plus y, I will get 1 plus 0 into 1 plus 0 into 1 plus 0. So all the time I will get 1 plus 0. Okay, all the time I will get 1 plus 0. So 1 plus 0 is 1. 1 into 1 plus y inverse is 1 plus y inverse. So you get this. So for next time, that is for fyy, you have to use the formula u v dash plus vu dash, or you have to bring it to the denominator, and you have to use the formula d by dx of u by v equal to vu dash minus u dash by v square. So now here, suppose if I am using the formula uv dash plus v dash, what is u? U is e power x. What is v dash? V dash is 1 plus y dash whole power minus 1. That is, on differentiating it, we get with respect to y, we get okay u dash plus v dash, but here we are having an advantage. What is that advantage? E power x is free from y. E power x is free from y, so it can be treated as constant. So only thing is you have to differentiate this. Okay, but for an ordinary differentiation case, you have to consider it as u dash plus v dash. Okay, but here, since if suppose I am having e power xy, suppose I am having e power xy into 1 plus y whole power minus 1, then you are having no other way, you have to use the formula uv dash plus v dash. But for this you are not having any worries to do u dash plus v dash, because e power x is constant. So e power x can be kept as it is, and the derivative of 1 plus y whole power minus 1 is minus 1 divided by n x power n minus 1. So minus 1 plus y whole power minus 2. So the minus will come in the front, and 1 plus y whole power minus 2. And f triple y will be minus will become plus, and you will get plus e power x 1 plus y whole power minus 3. So let us check f triple y. F triple x is n. So plus e power x 1 plus y whole power minus 3, n x power n minus 1. So 2 will come to the coefficient of e power x. So 2 e power x 1 plus y whole power 3. So now you know how to differentiate. All these terms, how to derive all these partial derivatives. So we are having the points. Substituting those points in those partial derivatives, we will have the values of those partial derivatives, and we have to substitute these values in the Taylor series expansion. And we are having e power x log of 1 plus y. So you can use f of x comma y, or you can use e power x log of 1 plus y. That is what function they have given for e power x log of 1 plus y. So those function can be written here. So on expansion we are getting this. Here what is h and what is k? H equal to x minus a, k equal to y minus b. H equal to x minus a, that is we are having h equal to, so I shall check the points. Okay, h equal to x minus a. So what is our a and b? What is our a and what is our b? Our a, so they have not mentioned what is a and what is b. Okay, they have not mentioned what is a and what is b. So we have to take the values of a and b as 0, 0 as our second subdivision of first problem, Okay, I hope you all understood how to solve any function, that is a function of x and y, using Taylor series. Now you know how to expand the function of f of x comma y by using Taylor series. I hope you all enjoyed the video. We shall meet on tomorrow's class on different topic. Thank you all for watching this video. Thank you all once again.